We are group 6 and we are working with the BBP valve work cell redesign. My name is Cole Armstrong.
I'm Brian Bourgeois.
I'm Corey Canzaneri.
Renee Pizzi.
Just a little background on BBP. They're a manufacturing rep for industrial equipment. They work with a lot of valves and sensors where they sell those, assemble those, repair those, and then send them out to other companies. And we are targeted with fixing, as you can see on the left, that's their current, or that was their current valve work cell. And so our goal has been to redesign that. And there's a group 7 is working with the sensors work cell, and they're trying to design that. So problem description. So the work cell that they currently have been using just isn't efficient as far as movement within the work cell. It's also not efficient within as far as taking into account how many workers they want to be able to have simultaneously going at the same time ergonomically. And so our goal was to just make the work cell smaller overall, but also increase or maintain the same capabilities of throughput that they already had. They want this work cell to be modular, so replicatable in all their future plants and other plants. They have a site in Birmingham, for example, that we've been able to work with a little bit. And so that was our target in designing the first semester. So this semester, we've been looking to validate that design that we recommended. You can go to the next slide, Renee. Objective. So specifically, we're looking to reduce the footprint of the work cell by 15%. We want to reduce the valve assembly time by our work cell design if possible. And so we'll do that by seeing where they're having to spend too much travel time and other non-value added movements, and see if we can get reduction by our design. We also want to do this through organization tips, 5S specifically. And then we also, as I stated, want it to be modular. And we also want it to improve the flow within the entire facility. So the last objective and kind of goal of us is to work with group 7 to implement and recommend a plant layout. I guess not implement, but recommend a plant layout to them by the end of the semester. And so within that plant layout, our work cell design has to be able to fit in and flow nicely with other departments.
So in order to validate and verify our design that we submitted, we have been doing some data collection and analysis. This is in the form of watching assembly videos that the BBP Birmingham facility sent us. And then through these videos, we're able to categorize the worker operations, then label them as value added or non-value added. These operations include tracking their idle time, travel time, tool and part drops, crane operation, and over processing, all of which are non-value added things. And then whenever we wanted to track their inspection time as well as their worker movement time, that adds value to the assembly itself. Those are the value added times. Once doing this, we can then track the cycle time fully of these operations that we get sent and compare it to last semester's data that we have.
So I'm going to go over some of the project setbacks that we've had over the course of this semester. So we're still having problems with actually getting observations with the valve assembly through the videos from Birmingham. We have been able to get a few, which I'll go over in the next slide. We still have not been able to get a visit with Flowserve, but we've kind of written that off because we've pretty much already done all the work that we would need that would have to be visited with Flowserve. We kind of wanted to visit with them to get an idea of how they have their work cell design over there. There were some videos sent to us that had angles that weren't too helpful, and I'll show some pictures in the next slide of that. We need to have more throughput data and financial data to get a general validation. So we're still working on that to be able to validate the entire work cell through our recommendations. We did have to consider changing the scope of our project due to lack of some of the observations that we had and lack of validation. And we were able to talk to Dr. Agazada about that and our sponsor to be able to fix these problems up and continue on with the original scope that we had. So here's the assembly videos that we had gotten. The first one took a while to receive on the left side here. And this angle is just inadequate for validation of the work cell. So we want to be able to see the entire movement of the worker and where he goes throughout the work cell, whether it's the crane or it's the tool chest or the bench stock or the tool wall, etc. We just need to be able to see where the worker is moving, not just what he's doing on the valve. So we were able to get another video from Birmingham, and here we can see it's a much better angle to be able to see the workers moving throughout the work cell and seeing more of what they're doing and how the movement is adapted to our recommendations.
Just to add something, Brian, so the reason that we're having to get videos is because the variation of our work cell that was implemented was done in Birmingham, not in Baton Rouge. And so that's why we're having to do these observations through recordings and videos rather than in person.
Yeah, thanks, Cole. So in the last picture, you can see that the workers are sitting on the ground or kneeling on the ground. So we want to try and implement some procedures where they would wear knee pads in those situations or have a rolling stool that they can store somewhere in the work cell and bring it out whenever they need to use it. And a more proactive thing to do would just get a floor vise that is adjustable to whatever height they need to be, so they're never bending down or anything like that. And in the picture, you also saw that the floor vise was not connected to the ground, which is definitely a safety hazard, as the valve could somehow tip over while it's being worked on. So we want to make sure that they can install the floor vise to the actual floor. They at one point put a forklift on the wood pallet to hold it down, which just seems very unsafe considering the workers aren't wearing any protective gear around the prongs of the forklift. We also want to make sure that the tool wall is labeled properly, because a lot of just clutter all over the workbench and the tool wall. So we want to make sure that we implement the 5S in there to have proper labeling for the tools.
So our current progress for the plant layout, step 1, team 7 went ahead and created a survey for the operators to answer regarding the importance of departments being near each other. And then team 6, we went ahead and converted that survey into a Google form to make it easier to collect data and analyze data. And that form pretty much has questions like, so for the sensor cell assembly and the glycerin filling station, how close do these departments need to be? Or how important is it that these departments are very close to each other? And they give a rating of unimportant, ordinary, important, very important, or absolutely necessary. And we gave each of those ratings a numerical value from 0 all the way up to 4. So 0 is unimportant, 4 is absolutely necessary. And then in step 3, we created our activity relationship chart, which you can see underneath the step 3. And yeah, it's got all the different departments we need: sensor cell assembly, all the way down to the valve staging area. And I gave them each a number in order to complete the next steps. So here's our activity relationship diagram or relationship chart again. And we use that in step 4 in order to create the nodal layout using the graph-based method. So in this method, you get the 2 departments that have the highest relationship. So that was department 7 and 8, which happened to be the valve assembly workstation and valve staging area. And their rating is a 3.5 out of 4. And you put those together. So those are at the top of the screen there. And then you find the next department that relates closest to both of those combined. So that happens to be department 5. That has the next highest relationship to department 7 and 8. And then you continue the process. So you do 7, 8, and 5 and find the department that relates the closest with them after that. And that's how you get this three-dimensional graph-based method for the nodal layout. For step 5, we created the nodal layout using the relationship diagramming method. So for this method, we converted our activity relationship chart into that relationship chart, which can be seen on the bottom left corner of the screen. In this chart, you put each department's rating added up. So like Department 1 is a sensor cell assembly. You put their department, or you add up each department's rating with each other with each of the other departments. So the sensor cell assembly is the highest rated department. So that is the most important in this method, all the way down to the least important being the glycerin filling station. And we use the department order of 1 to 5 to 4 to 3 to 7 to 6 to 8 to 2, from most important to least important. And that's the order you place them in this method. So we placed Department 1, and then 5, 4, and then so on, in order to create the top right corner, the nodal layout using the relationship diagramming method. And the next steps for our plant layout. So step 6, we're going to complete next week. We're going to go into BBP and collect the space requirements for each machine, piece of equipment, and department. Step 7, we're going to add the dimensions for the departments to the nodal layouts. That should probably be completed next week or the following week. And then step 8, we'll evaluate the 2 layouts to determine the better layout on distance and departmental relationships. That'll be completed in about 2 weeks. And then step 9, if we can get our hands on any software that can do plant layout design, we're gonna compare our design to a software generated one in order to ensure that we have the best design possible to propose to BBP.
All right, so lastly, we're going to deliver just 2 main things, which is going to be the completed valve work cell design. This will be used created based on the feedback we get from the current implementation. And through this, we can complete a cost analysis for the total cost of implementing one of these cells. And as stated earlier, we will then implement this design into the facilities design that we complete with Team 7. And so far, all we have left to do is to verify and update the valve work cell based on comments received from operators. Using the data analysis, we will be able to do this, and through operator interviews, we'll also get a better view as to what we really need to do in order to make this the most efficient and worker-friendly work cell as possible. Then after that, the facility layout design will then be completed, and we'll then be able to present our complete findings and recommendations for BBP in themselves. Thank you and have a good day.